What if the night Mars went silent? The universe answered back. On October 3rd, 2025, an interstellar object named 3I Atlas swept past the red planet, and within minutes, the impossible unfolded. NASA's rovers froze mid-transmission. A strange green flash erupted over Valles Marineris. Then 40 minutes later, Earth's own magnetic field began to pulse at the same frequency recorded on Mars. Coincidence or connection? The missing telemetry, the faint echo across space, and the data NASA quietly locked away all point to something far larger, an event that defied both physics and protocol. What if 3I Atlas didn't just pass through our solar system, but played it, triggering a cosmic resonance between two planets? Tonight, we follow the evidence NASA never explained, decoding patterns that suggest Mars and Earth may have shared more than a magnetic echo, perhaps a message. Stay until the end, because the silence may not be silence at all. The sudden data blackout. It began at the exact moment the world was watching. October 3rd, 2025, the scheduled Mars flyby of 3I Atlas, the third confirmed interstellar object to enter our solar system. NASA's live telemetry feeds for both Perseverance and Curiosity had been running flawlessly for months. Yet, as the object's trajectory closed in, something strange happened. Every feed went dark. The dashboards froze mid-sequence, timestamps stopped updating, and the usual cascade of background data, temperature, radiation, atmospheric reading, simply ceased. At first, observers assumed it was a temporary glitch. Mars communications occasionally experienced disruptions due to orbital alignment, but this wasn't one of those times. Both NASA's Deep Space Network and ESA's Mars Express orbiter had perfect line of sight. No solar storm warnings, no network anomalies. Yet for nearly 48 hours, silence. And when the feeds finally returned, they didn't resume from where they'd stopped. They resumed after the encounter, skipping the exact window everyone had been waiting for. Officially, NASA cited routine data buffering, but there was no mention of this buffer in mission logs or the DSN event calendar. Analysts who track these feeds daily noticed something more unsettling. The blackout wasn't random. It began within 90 seconds of 3I Atlas entering Mars's magnetospheric boundary, the invisible region where solar wind meets the planet's faint magnetic field. It was as if something about the object's passage had triggered a deliberate silence. The timing was uncanny. At that same moment, a minor power fluctuation rippled through DSN's Canberra station in Australia. Seconds later, the Goldstone facility in California logged a temporary data prioritization switch, effectively diverting all bandwidth away from public telemetry. If this was merely coincidence, it was a perfect one. The blackout raised an immediate question. If a NASA wasn't showing live data, who was still recording? That's when attention shifted to the European Space Agency. ESA's Mars Express had continued observing during the event, eventually releasing several faint images showing what appeared to be a green-tinged streak near the Martian limb. Yet even those were delayed, released nearly 36 hours after capture and heavily compressed. Why would ESA's images emerge faint, blurred, and incomplete when their instrumentation typically produces crisp imagery? Independent astronomers dug into the file metadata. Each image contained microsecond-level timestamp inconsistencies, tiny but real. In digital imaging, those offsets usually mean manual edits or delayed transmission. In other words, someone had touched the files before release. When questioned, ESA called it a sensor calibration variance, but the explanation didn't hold up under scrutiny. The variance appeared not across multiple images, but within a single one, as if layers from different moments had been merged. That's where the speculation began. Some proposed that NASA had intentionally ordered a radio silence protocol to avoid contamination of data during a strong electromagnetic event. Others suggested something more controlled, that the blackout was meant to contain visual evidence. something seen, something captured, but not yet meant for public eyes. Because when the data came back online, several instruments displayed new baseline values. Perseverance's magnetometer read slightly elevated background flux, not enough to trigger an alert, but enough to suggest that Mars' local magnetic field had shifted during the blackout. Radiation sensors showed similar anomalies, faint spikes consistent with a passing ionized field. That would normally point to a solar flare, except there were none. Space weather satellites monitoring the Sun reported no significant solar activity for that date. The solar wind was steady, so what could have caused simultaneous electromagnetic surges across two separate rovers in different regions of Mars, both at the exact moment 3I Atlas passed by? Some analysts noticed a pattern. Each time a probe or instrument pointed directly toward 3I Atlas's predicted trajectory, transmissions lagged. MAVEN's plasma sensor, which records charged particle interactions, reported a sudden data congestion event, a technical term that often masks electrical overloads. It was as though the object emitted a field strong enough to interfere with Mars' orbital network, even across hundreds of kilometers, and yet, if that's all it was, an electromagnetic disturbance, NASA would have said so. There's precedent. During Comet Siding Springs Flyby in 2014, NASA and ESA both documented interference in Mars' ionosphere. It was open science. Nothing to hide, but, this time, silence. Some insiders believe the blackout wasn't about protecting data. It was about containing context. When 3I Atlas approached Mars, its tail had already begun to behave unpredictably. Weeks earlier, Earth-based telescopes recorded the object's coma shrinking instead of expanding, the opposite of what comets do when nearing sunlight. Spectrographic readings showed an unusual mix of ionized metals and silicates, hinting it might not be a comet at all, but a rocky body with volatile traces, something between asteroid and engineered object. If NASA had high-resolution images of that structure, if its shape or activity looked artificial, anomalous, or simply unexplainable, then the blackout starts to look less like technical prudence and more like narrative control. After all, even NASA's raw imaging servers, typically filled with daily Rover thumbnail, went empty that day. But the story deepens further when you look at the timing. 43 minutes after the blackout began, Earth's magnetosphere registered a faint but measurable pulse, recorded independently by magnetometers in Alaska, Norway, and Japan. It was subtle, lasting only seconds. Space weather networks didn't issue alerts because the disturbance was below storm thresholds. Still, it was there. Could Mars's interaction with 3I Atlas have generated a magnetic echo strong enough to reach Earth? Or were both planets responding to a shared external field, something passing through the solar system, temporarily aligning them? The silence makes interpretation impossible. NASA hasn't published any data logs from that window. Internal review documents are sealed under the justification of interagency coordination, but historically, such coordination usually means one thing. Something was observed that agencies want to vet before public release in leaked fragments of conversation posted by a deep space network. Technician on a now-deleted forum. A phrase stood out: visual confirmation, field resonance. If genuine, it hints that something was seen and not just measured, something producing an observable reaction in Mars' atmosphere or magnetic envelope. In the absence of official statements, amateur astronomers have tried to reconstruct what happened. Using the timing of ESA's released frames, they calculated 3I Atlas's trajectory relative to Mars's dawn terminator. The geometry suggests the object passed close enough that its ion tail could have brushed the planet's upper atmosphere. If that interaction produced static discharges or auroral flashes, it might explain sudden surges in rover instruments and the blackout. But why hide that? Because such a finding would redefine how we understand interstellar visitors. If 3i Atlas could induce electromagnetic effects across planetary scales, it implies these objects are not passive drifters but active catalysts, carrying energy signatures that resonate through solar environments. That interpretation may sound speculative, but patterns are emerging. Oumuamua's trajectory defied simple gravitational modeling. Comet Borisov emitted compounds never before detected in interstellar objects. And now, 3i Atlas, the one that passed near Mars, coincides with global sensor disturbances and agency silence. Perhaps NASA's silence wasn't about secrecy. Perhaps it was about uncertainty, the kind scientists dread most. If the data reveals something that doesn't fit existing models, something that questions the limits of natural explanation, withholding it buys time to understand what they truly saw. Still, the optics are haunting. 48 hours of missing telemetry, a global audience waiting for the first interstellar encounter near another planet, and silence. Whatever happened over Mars that day, it left a digital scar, missing minutes, altered baselines, and a growing sense that not everything was under control. And as the object drifted away into the outer solar system, NASA's feeds came back as if nothing had happened. But the world had already noticed. Something did happen, and it started with a blackout that spoke louder than any transmission ever could. Faint images, altered metadata. When the silence broke, it wasn't NASA that spoke first. It was Europe. The European Space Agency quietly uploaded a small batch of images from the Mars Express orbiter, each labeled with an unassuming timestamp, 2025, 10:03 P11 UTC. They were meant to fill the vacuum left by NASA's absence. But instead of clarity, they raised more questions than they answered. At first glance, the pictures seemed ordinary. Mars' rust-red surface, thin clouds, and the faint curvature of its horizon. But then there was the anomaly, a soft green streak cutting diagonally across the frame, almost imperceptible until enhanced. Amateur astronomers on Reddit and Twitter began sharpening and layering the photos. The more they enhanced them, the stranger the streak became. It wasn't dust, nor an imaging artifact. It seemed to emit its own faint luminescence, a pale, almost bioluminescent hue, inconsistent with Martian reflectivity or sunlight scattering. Within hours, the ESA press office downplayed the images, calling them sensor calibration tests. But calibration tests don't usually happen during interstellar encounters, and they certainly don't explain what metadata analysts found next. Hidden inside the EXIF data, the digital fingerprint of every image, were slight timestamp inconsistencies. Each frame's embedded clock was off by microseconds, individually trivial, collectively impossible, because when ESA's own imaging system captures sequential frames, the timing remains synchronized down to the microsecond. These offsets, though minuscule, suggested post-processing, a manual stitch, as though someone had layered fragments from different moments to form a composite. And then came the second anomaly. The latitude-longitude coordinates embedded in the metadata pointed not to the region Mars Express was supposed to be imaging that day. Instead, they referenced an area nearly 700 kilometers off target, near Valles Marineris, the planet's colossal canyon system. This meant one of two things. Either the coordinates were altered, or the orbiter had turned its camera towards something unscheduled. ESA's official statement came 12 hours later. Routine calibration adjustments following unexpected solar particle interference. Yet no corresponding solar activity was recorded on that date. The sun was quiet. So where did this particle interference originate? Independent analysts digging into ESA's publicly accessible telemetry logs found something even more telling. At the moment those images were captured, Mars Express briefly switched to a manual exposure override mode. That function is almost never used, only when the automatic imaging system fails to adapt to sudden brightness changes. What could have caused Mars' night side to momentarily brighten enough to confuse the sensors? Some suggest it might have been 3I Atlas itself, a reflective flash as sunlight bounced off its surface, or perhaps a burst of plasma as it interacted with the thin Martian atmosphere. But others point out a disturbing coincidence. Similar faint green luminescence was detected in 2014 when comet Siding Spring brushed past Mars, bombarding it with ionized gas. That event produced a transient aurora, bright, brief, and visible only in ultraviolet wavelengths. But 3I Atlas's light was visible in optical wavelengths, a different class of phenomenon entirely. When the image streaks were enhanced by color frequency analysis, a recurring spectral peak emerged at 557.7 nanometers, the exact wavelength of oxygen aurora, the same green glow seen in Earth's polar skies. But Mars has no thick, oxygen-rich atmosphere. That emission line shouldn't exist there. Unless something had temporarily energized oxygen atoms already bound within Mars' carbon dioxide layer, exciting them to emit light, which led to an even stranger hypothesis that 3I Atlas might have emitted a burst of charged particles strong enough to trigger a localized aurora. A cosmic object that could create atmospheric excitation on another planet? That's not a comet. That's a reactor. The faint images might have been our first indirect proof. But the metadata tells an even more human story, one of hesitation. ESA's public release was accompanied by a technical note stating the files were filtered for noise reduction. The last time that phrase appeared in ESA documentation was in 2018, following the Rosetta mission, when a set of Comet 67P images was quietly altered to remove overexposed regions that, upon later review, contained bright, unidentified spots. History was repeating itself. NASA, meanwhile, remained silent. No mention of ESA's images on their feeds, no official retweets, no commentary from their Mars program scientists. Even the usually talkative Jet Propulsion Laboratory social accounts went quiet for 3 full days. It was as if both agencies had agreed, wordlessly, to let the story die. But the internet didn't. Within 48 hours, open-source investigators began cross-referencing the green streak's orientation with 3I Atlas's predicted trajectory. Using orbital elements published by the Minor Planet Center, they found a match within 0.3 degrees, well within observational error. The streak wasn't random. It was 3I Atlas itself. Yet that raised another issue. The object was expected to appear bright white or blue, not green. Spectroscopic data from earlier Earth-based observations had revealed magnesium and nickel signatures, metallic, reflective. So why did it appear green near Mars? Some speculated that its surface might have been coated with volatile compounds, perhaps frozen hydrocarbons or ionized silicates that fluoresced under solar wind impact. Others whispered of something less natural. A structure, a coating, a mechanism reacting deliberately. That theory found fuel in one overlooked fact. Mars Express had switched from automatic imaging to manual exposure mid-sequence. For that to happen, an onboard operator must have intervened, meaning the phenomenon was seen live and judged worthy of immediate adjustment. Whatever flashed across the Martian horizon, someone inside ESA Mission Control decided it wasn't noise. It was worth capturing manually, and yet, days later, only 3 faint, dimmed frames were released. Not the full data stream, not the high-resolution raw files, just 3, flattened, compressed, and low dynamic range. Enough to confirm something, but not enough to reveal what. Meanwhile, amateur astronomers analyzing background star patterns discovered another layer of oddity. The star alignment behind the green streak suggested the image had been slightly rotated, by less than a degree, but enough to throw off trajectory analysis. If unintentional, it's a minor calibration slip. But if intentional, it's a subtle way to obscure the object's true angle of motion. it wouldn't be the first time. In 2020, following Oumuamua's controversial detection, several observatories released centered versions of images that later turned out to have been cropped, a quiet way to suppress exact trajectory and brightness details. Could ESA, or another agency, be employing the same quiet redaction here? A leaked internal email from an ESA engineer, later removed from Reddit, allegedly mentioned luminosity offset normalization before publication. In plain terms, the images were darkened. Someone deliberately reduced exposure to hide over bright regions. If those regions were reflections, plasma bursts, or something metallic catching sunlight, the decision would make sense from a public relations standpoint. Because consider what an unedited version might show: an interstellar object, glowing faintly, interacting visibly with a planetary atmosphere, something that standard comet physics cannot explain. And perhaps most hauntingly, the faint streak seemed to originate not from deep space, but from behind Mars itself in the first frame, as though the object's trajectory had shifted mid-pass, an apparent curve inconsistent with pure gravitational motion. The simplest explanation: a visual illusion caused by orbital parallax. Mars Express moving while the object passed. But the ESA's own orientation logs show minimal rotation during that interval, meaning the curve could be real. If so, that curve implies acceleration, as though the object changed velocity even slightly. And that's what terrified theorists most. No natural body, especially an interstellar one, could perform a controlled adjustment while passing a planet's gravity well. And still, the agencies said nothing. No follow-up reports, no instrument comparisons, just silence. What we're left with is a handful of altered images, too faint to confirm, too strange to dismiss. A green glow that shouldn't exist. Metadata that points to human interference. And timing that aligns perfectly with the moment NASA's feeds went dark. It's as if the faint images were never meant to explain the blackout, only to fill the void it left. A placeholder for truth. And maybe that's the real message hidden in the metadata. Not what they showed us, but what they didn't. Because if the faint green streak wasn't a glitch, if it wasn't calibration, then it might have been something else entirely. A moment of contact disguised as compression, written off as static and buried beneath a few lines of metadata. A digital whisper from Mars, caught between two agencies, one camera and one object that may not have been what anyone expected at all. The magnetic pulse hit was just after 0314 UTC when MAVEN, NASA's Mars atmosphere and volatile evolution orbiter, recorded something that should not have been possible. A sudden spike in magnetic intensity surged through its instruments, lasting only 12 seconds. The reading was sharp, clean, and undeniable. A pulse, not noise. Normally, such spikes are caused by coronal mass ejections from the Sun or local atmospheric disturbances triggered by dust storms. But this was different. The Sun was quiet that night, the solar wind stable, and Mars was facing away from the Sun when the pulse occurred. The pulse's magnitude, approximately 14 nanoteslas above baseline, might sound small, but for Mars, it was extraordinary. The planet has no global magnetic field, only patchy remnants frozen in its crust. A field this strong, appearing out of nowhere, would have required immense external force. And the timing? It struck within 1 minute of 3I Atlas reaching Peri-Orion, its closest point to the planet. NASA's own logs initially listed the event as a localized magnetospheric deviation. Then, 48 hours later, that entry disappeared. The dataset was replaced by a sanitized version showing a perfectly flat reading for that entire interval. It was as if the pulse had never happened. But not everyone missed it. Amateur scientists who automatically archive MAVEN's real-time telemetry had already saved the original data, and when they compared it to archived readings from Earth's magnetometers in Norway, Alaska, and Japan, something impossible emerged. A faint echo of the same pulse appeared on Earth roughly 40 minutes later. Could Mars and Earth have shared a connected magnetic fluctuation across tens of millions of kilometers? That's where things begin to get uncomfortable. If it were a solar event, the propagation delay would have been hours, not minutes. If it were random coincidence, the waveforms wouldn't have matched. But they did, not perfectly, but eerily close. The pattern of rise and decay in Mars's pulse mirrored Earth's later echo. It was as though both planets had been brushed by the same invisible wave. NASA and ESA both declined to comment. Their press offices referred all questions to standard space weather variations. But space weather requires a source, and at that time the Sun's X-ray flux and proton output were flat. The Solar Dynamics Observatory reported nothing out of the ordinary. The anomaly forced a small community of independent physicists to reconsider what 3I Atlas might be. They began comparing its path to known solar magnetic field lines, plotting its entry and exit through heliospheric current sheets, the invisible planes of electric current that spiral through the solar system. To their astonishment, 3I Atlas crossed one of these sheets at the exact time of the Mars encounter. That means the object wasn't just passing through empty space, it was slicing through an electromagnetic boundary that connects planetary fields in subtle, poorly understood ways. Now imagine an interstellar object carrying its own charge, or its own residual magnetic field, from another star system. When such an object passes through the Sun's magnetic lattice, the interaction could create what some call a resonance flash, a momentary realignment of field lines that propagates like a wave through the solar medium. Could 3I Atlas have triggered one of these resonance flashes? MAVEN's instruments recorded a peculiar secondary signal during the pulse, a brief oscillation in the electron density of Mars's upper ionosphere. In other words, the planet's thin atmospheric plasma vibrated, like a drum responding to a shock wave. The frequency of this vibration, 4.83 Hz, matched almost perfectly with what's known as a Schumann resonance, the same natural frequency of Earth's electromagnetic cavity. That discovery, buried in data tables, gave rise to one of the most controversial ideas of the entire event, that Mars and Earth momentarily shared the same resonance pattern. If that were true, it would imply an electrical bridge of some kind, not a literal current, but a sympathetic oscillation. Two planets ringing together for a few seconds in the same cosmic key. The idea sounds poetic, but it sent a quiet panic through physics forums, because resonance requires synchronization. Something has to tune both systems at once. And in this case, that something was passing Mars at that exact moment, object that had already defied normal classifications. For NASA, this kind of data is a nightmare. A 12-second pulse might be dismissed easily, but not when it correlates with signals across multiple spacecraft and observatories. MAVEN's magnetometer isn't designed to malfunction. Its redundancy systems would have detected internal interference. Yet NASA's decision to retroactively alter the data record only deepened suspicion. Some engineers argued that MAVEN may have encountered charged dust particles from 3I Atlas's coma, temporarily distorting its field sensors. But the direction of the magnetic deviation pointed away from the comet's predicted trajectory, not toward it. That's a critical detail. It suggests the source wasn't the object itself, but something between the object and the planet. The ESA's Mars Express orbiter, observing from a different angle, registered a faint electrical discharge on its plasma detector at nearly the same second. It wasn't strong enough to constitute lightning, but it mirrored readings taken during the 2014 comet-siding spring event, when a comet showered Mars with ionized dust. Except this time, there was no dust plume, no visible debris, just energy. Somewhere deep inside NASA's Jet Propulsion Laboratory, a quiet debate reportedly erupted. Should they label the event as natural, or should they flag it for classified review under the Space Situational Awareness Protocols. A whistleblower hinted that internal memos referred to unidentified electromagnetic interaction. That phrasing, not anomaly, not glitch, but interaction, implies an exchange, a two-way event. If true, it would mark the first recorded case of an interstellar object producing measurable magnetic effects on a planetary scale. Meanwhile, back on Earth, the echo continued to haunt independent researchers. Magnetometers at polar research stations detected faint ripples consistent with low-frequency electromagnetic waves arriving roughly 40 minutes after the Mars pulse. This delay couldn't be accounted for by any known physical mechanism unless, as some speculated, the resonance traveled through interconnected solar plasma filaments linking Mars' orbit to Earth's. Think of it like plucking one string of a cosmic harp and hearing another vibrate in response. The coincidence doesn't end there. In the hours following the magnetic pulse, both Mars and Earth experienced slight increases in ionospheric density. Earth's upper atmosphere thickened unexpectedly, so slightly that only satellite drag measurements caught it. Mars's ionosphere too became denser, reflecting radar signals higher than usual. Two planets, separated by tens of millions of kilometers, both reacting subtly to the same invisible disturbance. Coincidence? Or coherence? No one at NASA has provided a definitive explanation. But deep in public archives you can still find the residual traces, the raw waveforms of Maven's instruments before the edits. When graphed, they reveal a symmetrical structure, rise, plateau, decay, eerily resembling an artificial signal pulse, like a transmitter testing its range. If 3i Atlas carried its own electromagnetic properties, remnants of an ancient interstellar magnetic field, then, as it entered Mars' environment, it might have discharged that energy. It could have acted like a moving capacitor, equalizing potential differences between magnetic regions in the solar wind. The resulting pulse would radiate outward in all directions, touching every conductive medium and including planetary ionospheres and the solar plasma web itself. Yet one question lingers: why delete the data? If it were natural, NASA would publicize it. A spontaneous magnetic surge would be headline-worthy. Instead, they buried it. Some suspect the data revealed field vectors inconsistent with known physics, perhaps a directional signature suggesting control or modulation. If the pulse had a repeating substructure, a coded oscillation rather than random noise, that would explain the quiet panic. Because then it wouldn't just be a magnetic wave, or it would be a message. Skeptics dismiss that as sensationalism. They argue that human error in data synchronization can produce similar artifacts. But as more researchers compared Maven's readings with the now-removed telemetry from the rovers, something chilling emerged. For approximately 11 seconds, the same duration as the magnetic pulse, both Perseverance and Curiosity stopped recording environmental data. Their systems didn't shut down, but their instruments paused, as if waiting for a signal to clear. The odds of that synchronization being accidental are astronomical. The story of the magnetic pulse remains one of the most baffling episodes in the history of Mars exploration. Officially, it never happened. Unofficially, it may have been the first measurable handshake between an interstellar traveler and a planetary world. Whatever its origin, natural, artificial, or something beyond either, the pulse left a signature in the data and in the silence that followed. It hinted at a universe not governed by isolation, but by resonance, a network of hidden connections waiting for the right vibration to awaken them. And on that October night, for 12 fleeting seconds, Mars might have sung back. Ground silence, the rover. Anomaly, for nearly a decade, the Mars rovers have been the heartbeat of interplanetary observation, transmitting a steady rhythm of images, sensor readings, and environmental logs. They are designed to endure dust storms, radiation spikes, and power fluctuations. Their silence is rare and never unexplained. Yet, on October 3rd, 2025, during the 3i Atlas flyby, both Curiosity and Perseverance went quiet at the same instant. At 03:12 UTC, their live data feeds halted mid-cycle. No gradual dropout, no corrupted packets, just a sudden stop. It was as if both rovers received the same invisible command to hold their breath. The pause lasted 7 hours and 38 minutes. When transmission resumed, something was missing. Not data loss, but continuity. The internal timestamps showed an unbroken operational clock, meaning the rovers were awake, powered, and functional during the blackout. Yet no telemetry, no weather readings, no navigation logs, not even wheel temperature data had been recorded in memory. It was a deliberate omission. NASA's official explanation, released 5 days later, cited scheduled uplink maintenance. But that statement contradicted the agency's own published operations calendar, which listed no maintenance activities during that sol. Moreover, the same explanation had never been used before, not in over a decade of Martian exploration. Amateur observers who track NASA's deep space network noticed something peculiar. The network didn't stop receiving signals from Mars, it stopped sending. For the entire blackout period, DSN stations in Canberra and Madrid maintained an open listening channel but transmitted nothing. Normally, both uplink and downlink channels operate in tandem. The decision to halt uplinks effectively rendered the rovers deaf. Someone had ordered Mars to go silent. Why? One possibility raised among mission engineers was a precaution against electromagnetic interference. 3i Atlas's passage, combined with the recorded magnetic pulse detected by MAVEN, might have risked damage to sensitive circuits. Putting the rovers into passive listening mode, receive only, could shield them from data corruption, but that explanation falls apart under scrutiny. Even in the event of cosmic interference, NASA's standard protocol is to switch to low-power safe mode, which still records basic environmental data for diagnostic purposes. That didn't happen. Both rovers remained fully powered, their systems running normally, but their recording subsystems disabled. It was not a safety precaution. It was a blackout, and the blackout coincided exactly, to the second, with the magnetic surge that rippled through Mars' upper atmosphere. At 03:14 UTC, Perseverance's ground sensors had been monitoring faint electrostatic fluctuations on Jezero crater's surface, routine data for measuring dust activity. But just before the silence began, its magnetometer registered a weak field variation, oscillating between 8 and 12 Hz. That frequency shouldn't exist on Mars. It's more characteristic of Schumann resonance on Earth, the natural electromagnetic pulse of lightning and atmosphere. Mars has no thunderstorms, no lightning, yet the signature was there. Then, the to-data stops. When the rover came back online, its next reading jumped forward 7 hours. No sign of power drain. No system fault. Just absence. Curiosity, 3,700 kilometers away in Gale Crater, experienced the same pattern. 2 rovers, 2 locations, 1 moment of silence. The chances of this being coincidence? Less than 1 in 10 billion. This pattern wasn't new either. Similar simultaneous data pauses occurred once before, during Comet Siding Springs flyby in 2014, but that event was preceded by heavy ion bombardment from comet dust. The 3i Atlas encounter, however, was supposedly clean. No visible debris, no particle trail dense enough to interfere. If not dust, what else could force 2 autonomous robots to stop recording at the same time? A leaked email thread from within JPL's mission support team, later shared anonymously on an astrophysics forum, offers a cryptic clue: protocol, sleep set, executed across surface assets due to unverified EM band detection. No such command exists in the rover's public command library. Sleep set sounds internal. Perhaps an emergency instruction reserved for classified experiments. A deep sleep state would normally preserve passive sensor data. Yet in this case, even the black box logs were blank. There's another layer to this mystery, one buried in the sound of silence itself. When radio engineers examined the raw carrier waves from the DSN receivers during the blackout, they discovered a faint, rhythmic modulation embedded in the static. It wasn't data, but an intermittent pulse repeating every 6.2 seconds. Too regular to be noise. Too weak to decode. It vanished the moment transmissions resumed. If the rovers weren't transmitting and DSN wasn't sending, where did that pulse originate? It appeared to come from Mars. At first, analysts suspected harmonic interference from 3I Atlas's passing tail, a plasma oscillation bouncing between Mars and the object's ion sheath. But calculations of trajectory and time delay didn't match. The modulation was stationary, as though transmitted from a fixed point on the surface. One unconfirmed report claimed that orbital spectrometers detected a faint infrared glow in Gale Crater, Curiosity's region, during the blackout. The glow lasted less than 10 minutes, fading as quickly as it appeared. It was dismissed as thermal noise, but the wavelength corresponded to ionized dust heated from below. In short, a heat signature with no visible source. Could 3I Atlas have induced electrical currents in the Martian crust, temporarily energizing surface materials? Or was something deeper, magnetic, mechanical, or otherwise, responding to its proximity? Whatever the cause, the result was eerily synchronized. Two machines separated by continents of red desert, reacting as one. That led to an unsettling hypothesis. Perhaps the blackout wasn't an external effect, but an internal command. NASA's systems operate on what's called autonomous safeguard protocols. These are lines of code that can trigger self-protection if unexpected environmental signals are detected. Radiation bursts, static interference, or electromagnetic surges. However, buried deep within the rover architecture are conditional flags, sequences that can only be activated by uplink commands from Earth. Someone on Earth may have preloaded such a command, timed precisely for the 3I Atlas encounter, instructing the rovers to temporarily suspend recording if a specific field strength or signal frequency was detected. If that's true, it means NASA expected something unusual. The question is, what did they expect to find? Perhaps they feared a solar flare coinciding with the flyby or a burst of cosmic radiation. But internal documentation later revealed no such forecasts. Maven's magnetometer logs prior to the event show calm conditions. The only new variable was 3I Atlas itself. Was the silence a precaution or a cover? There's precedent for the latter. During the Apollo 11 mission, audio transmissions were briefly muted for 2 minutes, while astronauts described light reflections on the lunar surface, later dismissed as glare. Those missing minutes have been debated for decades. The Mars blackout mirrors that same chilling pattern, just longer, quieter, and digital. Adding to the mystery, when the rovers resumed transmission, both exhibited minor calibration drifts. Curiosity's atmospheric pressure readings were off by 0.02 pascals, trivial but unexplained. Perseverance's navigation cameras, usually sharp to sub-pixel precision, showed slight misalignment, as though their internal gyros had been magnetically disturbed. It's as if both machines experienced a subtle electromagnetic tremor, the kind that could alter orientation sensors but not damage hardware. NASA brushed off these anomalies as routine recalibration. But the timing, once again, was too perfect. When engineers replayed the onboard event logs, they found ghost entries in timestamps without data, empty frames in the mission timeline, digital absences that shouldn't exist, and yet the most haunting clue may come from sound. The SuperCam microphone aboard Perseverance, which occasionally records ambient audio for Dust Devil research, captured faint static bursts just before the silence began. In the final 3 seconds of audio before the cutoff, a deep, low-frequency hum fades in and out, steady, rhythmic, almost harmonic. It was unlike the whine of motors or the howl of wind. It pulsed faintly, but deliberately. If you isolate the waveform, the hum follows the same 6.2-second cycle as the DSN's received modulation. That means both signals, the surface hum and the deep space radio echo, were synchronized. 2 worlds, 1 sound. When the audio resumed hours later, the hum was gone. The Martian wind had returned, but the memory of that pattern lingered, embedded in code archived in silence. Could it have been a planetary response, an electromagnetic vibration induced by 3I Atlas's proximity, or something else entirely, something intelligent hidden in the magnetic resonance? No one can say. The recordings have not been released publicly. Only snippets exist, circulated quietly among researchers who describe the sound as unnervingly organic. To this day, NASA refuses to clarify whether Sleepset was real. But those who've studied the event say the rover's silence was not an absence of data. It was the presence of control, as if Mars itself was instructed to stop listening, or perhaps more hauntingly, to listen to something else. Atmospheric flash over Valles Marineris at SO 317 UTC, just 4 minutes after the rovers went dark and Maven's magnetometer spiked. Another anomaly unfolded, this time over Valles Marineris, the largest canyon in the solar system. The event lasted less than 10 seconds, yet its implications ripple through every dataset NASA and ESA have since refused to discuss. The flash was first recorded by the Mars Reconnaissance Orbiter's Marcy camera, which scans the atmosphere for dust patterns and seasonal storms. The instrument isn't meant to capture transient light bursts. It operates in ultraviolet and blue bands, but the flash was so intense that it oversaturated 2 consecutive frames. When the exposure logs were examined, the brightness exceeded the level of any known Martian lightning or reflection. On paper, it shouldn't have happened. Mars is a dry planet, with an atmosphere less than 1% as thick as Earth's. Electrical discharges can occur during massive dust storms, but no storm was active over the canyon that night. The region's skies were clear. And yet, something had produced a light equivalent to a small nuclear detonation, though without heat or shockwave. The official explanation released briefly on ESA's Mars Express site before being quietly deleted, claimed it was a sunlight glint off atmospheric ice crystals. But astronomers were quick to point out that at the time of the event, the sun was well below Mars's local horizon. Valles Marineris was in deep shadow. There was nothing for sunlight to reflect off. For days, the flash existed only in whispers, a rumor among satellite watchers, an oddity discussed in obscure forums. Then an image surfaced, a single blurred still extracted from the Thermal Emission Imaging System, THEMIS, on NASA's Mars Odyssey orbiter. The image wasn't part of any scheduled observation. It was a background scan, meant to record surface temperature gradients. But for one frame, its sensors flared white. The temperature spike was real, but only for a moment. The data shows no residual heat pattern, no lasting thermal footprint on the ground. Something brightened the Martian atmosphere without heating it. Scientists call that non-thermal emission, a phenomenon usually associated with plasma, auroras, or high-energy radiation bursts. But this flash was localized, not diffuse. It came from a point roughly 30 kilometers above the canyon floor, suspended in midair, where there are no storms, no satellites, no aircraft, and the timing was eerie. The flash occurred at the exact moment ESA's faint green streak was passing the planet's limb, when 3I Atlas was closest to Mars. The trajectory projected across the equatorial region, placing its peri-Orion almost directly above Valles Marineris. So, what could cause an atmospheric burst of light without impact, heat, or debris? One theory points to electrical excitation, a sudden surge of charged particles colliding with thin CO2 molecules, creating a temporary auroral flash. But Mars has no magnetic field strong enough to focus such an event. For it to occur naturally, something would have to inject a dense packet of energy, perhaps a magnetic pulse from the interstellar object itself. MAVEN's plasma wave detector did, in fact, record a strange burst at that exact timestamp, a narrow band frequency oscillation that climbed from 4 to 9 kHz before vanishing. That's a frequency range associated with terrestrial lightning whistlers, the electromagnetic echoes lightning creates when it bounces between Earth's ionosphere and magnetic field lines. The coincidence was impossible to ignore. If Mars had no storm, what created its lightning? Unreleased mission chatter may hold a clue. A leaked internal message, allegedly from a European Space Operations Center technician, described an optical transient consistent with an atmospheric discharge event and noted that it was visible in both IR and UV channels, but absent from thermal. The phrase optical transient is agency shorthand for something unexpected but undeniable. When independent analysts attempted to triangulate the flash's location using data from orbiters, they found something even stranger. The point of origin wasn't fixed on the planet. It appeared to move slightly upward during the event, as if something ascended through the atmosphere. Each frame placed the light source a few hundred meters higher than the last. That vertical climb, roughly 2.4 kilometers in 10 seconds, was too slow for an explosion, too fast for natural convection. It suggested propulsion. Of course, that interpretation is radioactive in scientific circles. To propose motion implies structure. To imply structure suggests intent. So the official line became silence. But silence has its own signature. In the following days, all high-resolution imaging requests for Valles Marineris from both NASA and ESA were quietly deferred. Orbiters that normally photographed the canyon weekly didn't revisit the region for over 3 weeks. That kind of scheduling freeze is unprecedented. Only once before had an entire region of Mars been embargoed from observation after the crash of the Schiaparelli lander in 2016, when agencies feared misinterpreting debris as anomalies. So why repeat that silence now when no crash had occurred? One unconfirmed source inside JPL's navigation division claimed that during the flash, multiple orbiters reported minor orientation disturbances. Mars reconnaissance orbiters' star trackers lost lock for several seconds. Mars Odyssey registered a yaw deviation of 0.02 degrees. Those are microscopic changes, but they suggest the spacecraft experienced a brief external torque. A passing electromagnetic pulse could do that. So could an atmospheric shockwave invisible to thermal sensors. If such a pulse originated from the same region as the flash, it might explain the rover's simultaneous blackout. Think of the timing chain. The object approaches. A magnetic surge ripples through Mars. Rovers go silent. A flash erupts over the planet's largest canyon. Then, as the light fades, transmission resumes. A sequence too coordinated to be coincidence. The next question was the color. Unlike a meteor or flare, the flash wasn't white. It was green. When the images were enhanced, spectral analysis placed its dominant emission line near 557 nanometers, the same oxygen wavelength seen in the earlier ESA images. This connected event to event, the faint streak, the magnetic pulse, and now the atmospheric flash, all radiating the same eerie green signature. That line belongs to forbidden oxygen transitions, the kind that occur only in low-density gas under specific electrical excitation. Earth's auroras display it frequently. On Mars, however, such emissions are nearly impossible without outside stimulation. This detail resurrected an old, forgotten hypothesis from the 1970s Viking missions that Mars' upper atmosphere occasionally experiences transient luminescent events triggered by cosmic or solar anomalies. But even then, those were theoretical, never observed. Until now. The flash may have been Mars' first documented auroral discharge, except it occurred in a place and time where it shouldn't, and with energy levels no natural source could explain. Somewhere in this chaos of data and denials lies a darker possibility. Suppose 3I Atlas wasn't just reflecting light, it was emitting it. An object charged through interstellar plasma could accumulate electrical potential far beyond what human probes experience. When it passed through Mars' ionosphere, that charge might have discharged, momentarily ionizing the thin atmosphere. A cosmic capacitor releasing its stored energy, lighting up the sky like a silent detonation. But another theory, whispered in late-night science boards, goes further. What if the flash wasn't a discharge at all? What if it was a reaction, Mars responding to something? There are ancient magnetic scars in Valles Marineris, zones of remnant crustal magnetization buried deep beneath the canyon floor. If 3I Atlas emitted a magnetic pulse, those rocks could have momentarily reactivated, creating localized induction currents. The resulting ionization could rise through the canyon's thin air like a luminous column, producing the illusion of an upward-moving flash. That would explain the vertical motion, light climbing out of the canyon as the field surged upward, a planetary reflex. Mars speaking back briefly to an interstellar visitor. NASA hasn't commented on the flash since. The Marcy frames that captured it remain unlisted in the agency's database. The only reason we know they exist is because one copy was mirrored on a European cloud server before removal. When independent researchers requested access to the raw imagery under the Freedom of Information Act, NASA's response was terse. Data temporarily withheld pending internal review. That was 6 months ago. No further updates. Meanwhile, amateur telescopes around the world began reporting something subtle yet persistent, a faint atmospheric glow around the same longitude on Mars, detectable only in high-exposure images taken at dawn and dusk. The glow fades daily but returns cyclically every few sols. It's as if the canyon remembers. If that's true, then the October 3 flash was not a singular event. It was the ignition of a lingering process, perhaps a remnant charge, perhaps something deeper. And if 3I Atlas was the catalyst, the question becomes, what did it awaken? Was the flash an accident of physics or the first visible evidence that Mars's ancient magnetic heart can still beat under the right cosmic touch? Whatever the truth, the pattern is impossible to ignore. Magnetic pulse. Ground silence. Flash in the canyon. A choreography unfolding in minutes across a dead world. For now, all that remains are faint pixels and a widening silence. Echoes in Earth's sensors. The pulse should have died on Mars. It should have ended there, an isolated atmospheric quirk, a magnetic blip confined to a silent world. But 40 minutes later, on the other side of the solar system, Earth trembled. Not in the way tectonic plates grind or storms roar, but through instruments built to measure the invisible. Across observatories, seismographs, and ionospheric stations, faint signatures began to ripple through the data. Coordinated, global, and inexplicable. It started in Kiruna, Sweden, where magnetometers tracking auroral activity detected a pulse. Not a curve or a flare, but a crisp singular spike. Its frequency matched the one recorded by NASA's MAVEN probe during the Mars event. 483 Hz. The same pattern, the same pulse shape, the same rise and decay curve, only scaled down, as if echoing from afar. Minutes later, Japan's Kakioka Observatory reported a near-identical signal. In Alaska, the Poker Flat radar network noted a non-terrestrial modulation in the ionosphere, followed by a minor fluctuation in atmospheric electron density. All of it synchronized, delayed by roughly 40 minutes from the Mars magnetic surge. Coincidence? The odds are astronomical, and yet the timeline aligns perfectly with the solar plasma travel time between Mars orbit and Earth's. If the disturbance propagated through the heliospheric current sheet, the vast electromagnetic structure threading the solar system, that sheet is like an invisible ocean of charge rippling between planets. When something disturbs it, say an interstellar object with a magnetic field of its own, the ripples travel outward, touching every world in their path. The numbers don't lie. The 40-minute delay corresponds almost exactly to a disturbance moving at 1/200 kilometers per second, far faster than solar wind, but consistent with shock waves observed during interplanetary magnetic reconnection events. NASA's official channels were silent, but space weather enthusiasts noticed something odd. The DSCOVR satellite, stationed at Earth's L1 point, suddenly switched to data-pending mode during the same minute the pulse reached Earth. For 3 hours, it transmitted nothing. When the feed resumed, its magnetometer readings were conspicuously smooth, too smooth, missing the natural noise background. That's when independent researchers began to compare the data sets. When they overlaid MAVEN's pulse from Mars with Earth's later echo, the waveforms aligned almost perfectly, except one was inverted. Positive to negative, like the reverse pole of the same signal, as if Mars had exhaled and Earth had breathed it in. It didn't stop at magnetometers. Seismic networks, the most grounded of instruments, started reporting subtle, rhythmic vibrations. Not earthquakes, micro-oscillations. The U.S. Geological Survey logged dozens of non-seismic events over a 30-minute window centered around the pulse arrival time. Small, harmless, but synchronized across continents. The oscillations were in the 0.01–0.03 Hz range, far below human hearing. The same range sometimes triggered by massive solar storms coupling with Earth's ionosphere. But there was no storm, no solar wind burst, no coronal mass ejection. The sun's face was calm, spotless, asleep. Whatever shook Earth came from somewhere else. In Chile, researchers at the Atacama Geophysical Array noticed a faint magnetic resonance sweeping northward, recorded first in the southern hemisphere, then propagating across the equator in under 6 minutes. The direction pointed almost perfectly along the Sun-Mars line. The implication was staggering. Energy from the Mars flyby may have traveled directly through the solar medium and brushed Earth's magnetic shell, like a ghost signal from the red planet. If true, this would be the first documented planet-to-planet magnetic coupling event ever recorded. And then, something even stranger. Atmospheric sensors in Iceland and Greenland picked up minute temperature anomalies, less than 1/10 of a degree, occurring simultaneously with the magnetic fluctuations, a nearly imperceptible warming of the upper atmosphere. When correlated with ionospheric radar data, the heat signatures corresponded to increased electron densities at altitudes between 90 and 110 kilometers. That's the same layer where auroras form. But there were no auroras that night. The skies were clear, yet instruments detected the unmistakable fingerprints of energy injection. Around the same time, a series of low-frequency radio bursts were logged by amateur astronomers monitoring Jupiter's decometric emissions. These observers often pick up background static from the outer planets. But what they heard that night didn't match Jupiter's natural patterns. The bursts were evenly spaced, fading in and out every 6.2 seconds, the same rhythm embedded in Mars's radio silence earlier that night. The coincidence sent shockwaves through the small but obsessive world of independent radio astronomers. To them, it looked like a signal chain. Mars receives, Earth echoes, space hums. By dawn, theories were erupting across forums. Was the 3i Atlas flyby releasing electromagnetic energy through interplanetary plasma? Could Mars-induced magnetic surge have wrung the solar current sheet, sending harmonic vibrations across the system? Or, the wildest suggestion, Was the pattern an intelligent modulation carried across planetary fields like a coded resonance? NASA dismissed these discussions as pseudoscience, but insiders whispered a different story. A whistleblower from the Goddard Space Flight Center, whose credentials checked out but identity remains concealed, allegedly leaked a snippet of an internal briefing document. The summary line read, "Correlation confirmed between Martian magnetospheric event and terrestrial anomaly. Probability of causal relationship, 0.92, 92% certainty. That's not speculation. That's acknowledgement." But the most haunting revelation came days later from an unexpected source, the Global Seismographic Network. Data visualizations showed that the micro-oscillations on Earth didn't fade immediately. Instead, they repeated, weaker, yes, but rhythmic, every 4.8 hours for the next 2 days, as if something was still pulsing, like an echo that refused to die. Every wave matched the harmonic interval of the original signal. A persistent tremor resonating through Earth's crust, ionosphere, and magnetic field, all connected by a pulse that started millions of kilometers away. Some analysts suggested that 3I Atlas might have passed through a solar magnetic null point, briefly realigning planetary field lines. If its trajectory intersected the same magnetic sheet linking Mars and Earth, it could have plucked that cosmic string, the way a pebble thrown in water sends ripples to every shore. But others argued something deeper. Maybe it wasn't just energy transfer. Maybe it was response, because if Mars' pulse created a resonance on Earth, something on our planet reacted. Certain magnetometers in Europe and North America showed secondary peaks, smaller, but phase-shifted, as though Earth's field was not just receiving, but answering. That realization led to a disturbing speculation among plasma physicists. If 3I Atlas's field could induce resonance across planetary magnetic systems, then the solar system isn't just a collection of worlds. It's a single resonant circuit. Each planet, a node, each magnetic field, a coil, each pulse, a conversation. And perhaps, on that night, something knocked on the line. The next morning, scientists at Stanford's VLF research group recorded unexplained fluctuations in the ionospheric cavity, faint radio murmurs just above the noise floor. They described them as chorus-like, structured, and unusually stable. Not random static, patterns. The intervals between pulses followed a repeating prime sequence, 2, 3, 5, 7, 11 seconds. In nature, randomness dominates electromagnetic noise. Prime number spacing, however, is statistically impossible unless it's generated. When confronted, NASA refused to comment on non-verified civilian data. But a European researcher, speaking anonymously, claimed ESA's deep space antenna in New Nausea detected a brief alignment event, a narrowing of background noise at the exact same frequencies. Something had synchronized. Whether natural or engineered, it left fingerprints everywhere, say in the air, in the ground, and perhaps even within us. Because in the hours following the pulse, a spike in human Schumann resonance monitoring, devices used by bioelectromagnetic researchers, showed increased activity at 7.8 Hz, the same frequency associated with both Earth's resonance and human brain alpha waves. For some, it was nothing more than coincidence. For others, it suggested an unnerving thought. The echo may have reached deeper than the atmosphere, perhaps into the very electromagnetic rhythm of life itself. By the time agencies restored their sanitized datasets, the true signal had already been overwritten, but the independent archives remain messy, fragmented, and raw. When pieced together, they trace a timeline impossible to ignore. 0314 UTC, magnetic surge on Mars. 0317 UTC, atmospheric flash over Valles Marineris. 0352 UTC, Mars rover silent. 035604 UTC, pulse detected on Earth. 0440 UTC onward, residual oscillations repeating in global sensors. A planetary chain reaction, one planet shuddering in response to another. If energy can leap through the solar current sheet, if interstellar objects can tune that resonance, then 3i Atlas may not just be passing through space, it may be playing it. And for 40 minutes that night, the universe hummed from Mars to Earth, as if answering a question we didn't realize we'd asked. The missing telemetry burst at 0311 UTC. The moment ESA's faint green streak was captured, a curious anomaly appeared in the logs of NASA's Deep Space Network, DSN. It was small, buried in a stream of automated telemetry, the kind of thing only data archivists ever notice. Yet, this single entry would soon become the center of the most debated blackout in modern space history. The record referred to a telemetry burst event originating from Mars orbit, transmitted by one of NASA's relay satellites, likely the Mars Relay Network, which connects orbiters and surface rovers. The data packet was enormous, nearly 40% larger than any standard downlink ever recorded during that mission cycle. Then, moments later, the relay channel went silent. No continuation, no acknowledgement signal, nothing. What makes this burst so strange is not just its size, it's when and how it happened. The timestamp matches precisely the minute ESA's low-resolution frames of 3i Atlas were taken, and just 2 minutes before, MAVEN's magnetometer spiked with the now infamous magnetic pulse. In other words, at the exact moment multiple spacecraft observed something extraordinary near Mars, a data packet far too large for routine telemetry and too short for any scheduled transmission erupted through NASA's network and was immediately buried. When technicians later accessed the archive, the packet had been truncated. The file header was intact, but the payload data, made of the binary core, had been overwritten with a blank placeholder. Officially, it was reclassified as checksum error, unverified transmission. That term is bureaucratic code for "we don't want to talk about it." To anyone familiar with space data systems, that's a red flag. A checksum error usually arises when data corruption occurs due to interference, but the DSN's error logs show no evidence of degraded signal integrity that night. The transmission was clear, strong, and complete, then manually deleted after review. Why? Because the raw packet size and structure didn't match any known template for rover telemetry, orbiter health data, or system diagnostics. Instead of the usual scientific data sets, neatly segmented by instrument ID and timestamp, this burst appeared as a continuous binary stream. No breaks, no internal markers. Almost like video. If true, that would mean that. For less than 30 seconds, NASA received what may have been the only real-time imagery of the 3i Atlas flyby from orbit, perhaps captured by a high-bandwidth camera on either Mars reconnaissance, orbiter, or the trace gas orbiter, and then, as quickly as it came, it was gone. Theories exploded. Some claimed the data was too unstable to decode, others insisted it was too revealing, because if it contained images, or worse, signals, that defied explanation, deletion would be easier than disclosure. Let's step back. Every transmission from Mars follows a specific routing path: rover, orbiter, relay satellite, DSN ground station. Each link is timestamped and logged. For the 03 to 11 UTC window, all upstream nodes report nominal status, except for the Mars relay. Its carrier continuity entry ends abruptly at 03:11:34 and does not resume until 03:16:48. That's a 5-minute gap, during which the burst occurred. Whatever the relay transmitted, it wasn't normal science data. An independent analysis of the DSN logs by the SETI Technical Review Group revealed faint irregularities in the ground station frequency offsets during that 5-minute window are micro shifts that suggest manual frequency reallocation. In plainer language, someone changed the channel. One possible reason? To divert the incoming data to a restricted subnet. That subnet, known internally as Network Segment 43A, is reserved for classified payloads or mission-critical testing. But it hasn't been used in years. It's effectively a digital vault for data NASA doesn't want mirrored to public archives. And during that October thaw window, it came alive for the first time since 2018. Coincidence? Unlikely. The relay's metadata confirms an encrypted link handshake at 03:11:09. That means the burst was received, flagged, and redirected, all within seconds. Someone was waiting for it. What could they have been expecting? To answer that, we look at Maven's secondary logs. While its primary magnetometer data was later revised, a backup channel recorded a spike in high-frequency electromagnetic noise at 03:11:11 UTC, a tier band usually associated with digital transmissions, not natural phenomena. This noise was strong enough to saturate Maven's receivers for 2 seconds. So, Mars emits a mysterious electromagnetic surge. DSN receives an oversized telemetry burst. Maven's instruments glitch. And the moment passes into silence. The implications are staggering. The simplest theory is that the burst was an automatic emergency dump, a failsafe triggered by one of Mars's orbiters after detecting a radiation event or instrument overload. But this doesn't fit the telemetry profile. Automated dumps use redundancy encoding and are spread across multiple packets. The 03:11 event was one continuous dump, raw, uncompressed, and point-to-point. That kind of transmission suggests deliberate action, not automation, which leads to a chilling possibility. An orbiter may have sent something directly back to Earth, not as data collection, but as a warning. The missing packet could contain the only record of what truly unfolded near 3I Atlas. Now let's look at the numbers. Using the packet size and the bit rate of the Mars relay network, 256 kbps, the burst would equate to roughly 96 megabytes, far larger than a status report, but roughly the size of several high-resolution compressed images, or a 20-second video feed. This is where it gets even stranger. In NASA's internal file tracking index, that transmission is labeled Imaging Series 3IAM, which doesn't correspond to any known Mars mission. 3IA, 3I Atlas, appears nowhere else in NASA's naming conventions. It was as if someone created a temporary file designation just for that event, and then erased it. According to a whistleblower who claims to have worked on DSN archival validation, the burst contained frame markers inconsistent with human-made imaging compression. In other words, whatever was inside didn't behave like data from a camera. Its bit intervals were uneven, organic, almost rhythmic. That statement has never been verified, but it echoes earlier rumors about NASA's deletion of similar signals during the Oumuamua event in 2017, where non-linear telemetry spikes were logged and later dismissed as cosmic. Rays. Patterns repeat after October 3rd. The DSN schedule showed a sharp rise in restricted data transfers lasting 2 weeks, likely reprocessing of the lost burst. But when the FOIA requests poured in, NASA declined, citing national security implications. National security? For a comet? That phrase alone ignited speculation that the data had been diverted not to NASA's archives, but to U.S. Space Command's Space Domain Awareness Network, the classified system responsible for tracking unidentified spaceborne objects. If 3I Atlas's behavior triggered protocols in that system, the reason would have to be extraordinary. But there's one more piece, and it might be the most disturbing. During that same 5-minute window, a small observatory in Canberra, Australia, which monitors DSN telemetry reflections, recorded a secondary echo. A weak return ping that shouldn't exist. Normally DSN uplinks are one way, but this time the signal bounced back. A reply. The echo's delay, 22 milliseconds, matched perfectly the round-trip light time between Earth and the Moon, not Mars. Some theorized it was an internal loopback. Others saw it as something else, a rebroadcast, possibly from a relay satellite misdirected by interference. But when plotted on a spectral analyzer, the echo contained a pulse structure, a sharp peak followed by two diminishing harmonics. And when translated into frequency ratios, those harmonics formed a simple mathematical relationship. 1, 2, 2. That ratio doesn't occur naturally in random static. Geometric, harmonic, coincidence? Possibly intentional? Impossible to rule out. NASA never acknowledged the echo, but the data remains publicly accessible, a ghost in the static. It's weak, almost inaudible, but it's there. A whisper buried in the noise floor of humanity's longest-running experiment in interplanetary communication. If it's real, then maybe, just maybe, the missing telemetry burst wasn't lost. Maybe it was answered. And if that's true, then the silence that followed wasn't emptiness. It was listening. Pattern beyond coincidence. When investigators laid the entire timeline out, every spike, silence, and signal, what emerged no longer looked like random chaos. It looked like design. Not human design necessarily, but a pattern that obeyed a rhythm deeper than coincidence. A chain of events so tightly interlocked that probability alone could no longer explain it. At 0311 UTC, a telemetry burst erupts, larger than any standard Mars transmission. At 0314, Maven's magnetometer records a surge in field strength, clean, measurable, precise. At 0317, a flash illuminates the sky above Valles Marineris, seen simultaneously in ultraviolet, infrared, and visible light. By 0352, both Perseverance and Curiosity go dark, their feeds halted midstream, and at 0356, 40 million miles away, Earth's own magnetic field flutters in the same frequency range. 5 discrete events, all within a 45-minute window, all connected by the presence of one object, 3I Atlas, the interstellar visitor, whose origin still cannot be pinned to any known trajectory from the local stellar neighborhood. This wasn't random interference. It was a synchronized chain reaction. The geometry of the impossible astrophysicist Dr. Renata Singh, an independent data analyst once contracted for the Maven mission, described the correlation in stark terms. You're looking at a multi-body electromagnetic resonance. Something injected energy into Mars' environment, and that energy propagated through the heliospheric medium at a speed too high for solar wind, but too low for particle radiation. That's not a natural propagation mode. It's controlled coupling. Her analysis suggested that each planetary field, Mars, Earth, even minor readings from the Moon's magnetotail, reacted not as separate systems, but as harmonic oscillators locked momentarily into the same frequency. The same 4.83 Hz pulse, the same waveform inversion between Mars and Earth. Natural processes don't synchronize like that, especially across astronomical distances, unless something tuned them. The geometry itself becomes damning evidence. When you map the line of sight from Mars during the flyby, Earth and the Sun form an almost perfect alignment. What orbital scientists call a syzygy, a gravitational and magnetic bridge connecting all three bodies. The odds of 3I Atlas intersecting that alignment by chance? Less than 0.1%, and yet it did, too. Resonant planetary chain in 2019, physicists studying solar-terrestrial interactions proposed that under certain magnetic alignments, planets can whisper to one another through field resonance, tiny electromagnetic ripples that travel along the heliospheric current sheet. The idea was dismissed as fringe theory, but the October 3 event fits that model perfectly. If 3I Atlas carried even a weak residual magnetic field and frozen from its birth around another star, its passage through Mars's induced magnetosphere could have triggered a field realignment event. Picture plucking one string in a cosmic harp and hearing another vibrate across the room. Except this time, the vibration wasn't metaphorical. It was measurable. Multiple ground-based observatories on Earth detected the echo with uncanny precision. The lag time matched the theoretical propagation delay between Mars and Earth through the current sheet. That's physics, not fantasy, and yet the frequencies were too clean, too stable. Singh compared the signal to a controlled pulse, akin to radar chirps or active sonar. A short burst meant to provoke a response. If you wanted to test the resonance properties of planetary magnetic fields, she wrote, this is exactly how you do it. Historical parallels. Hidden in plain sight, this wasn't the first time our instruments had sung in sympathy with a passing object. When Oumuamua swept through the inner solar system in 2017, magnetometer networks registered an almost imperceptible phase shift, dismissed then as processing noise. In 2019, during Comet Borisov's perihelion, plasma detectors across 2 different missions recorded unexplained harmonics at precisely twice the comet's rotation frequency. 3 interstellar visitors, 3 correlated field disturbances, and now 3I Atlas, the first to pass close enough to a planet to show what the earlier signals only hinted at. A sequence stretching across 8 years, forming an unmistakable crescendo. A pattern unfolding in cosmic time. The suppressed data set inside NASA's publicly accessible repositories, there are gaps, missing timestamps that correspond exactly to the critical windows of each anomaly. When independent researchers attempted to reconstruct the data continuity, they found systematic truncations, files replaced with lower-resolution surrogates or marked pending validation. Those gaps are not technical errors. They're deliberate edits. A whistleblower from within the Jet Propulsion Laboratory, writing under the alias Kalis, described internal discussions following the 3I Atlas flyby. We were told to isolate the anomalous packets.
Not delete them, isolate.
The reasoning given was to prevent misinterpretation until multi-agency review. But the review never came. The packets never resurfaced. If true, that means NASA and ESA may be sitting on a high-fidelity record of the event, possibly imagery of the flash or raw telemetry from orbiters during the magnetic pulse, withheld not for national security, but because the implications exceed what official science can comfortably explain. A planet responds. When MAVEN's data was finally re-examined months later, researchers noticed something else, a faint oscillation following the magnetic pulse. It wasn't just a spike and decay. The field vibrated for several minutes afterward, stabilizing at an amplitude too consistent to be random noise. It looked like feedback, like Mars was echoing the signal it had received. Now combine that with the rover's simultaneous silence. Both machines forced into passive state at the moment of peak energy. And you begin to see why some insiders believe Mars didn't merely experience the event. It participated in it, whether by physics or by design. The red planet seemed to act as a resonant node in a circuit linking 2 worlds. The Earthside aftermath. When the echo reached Earth, magnetometers registered inverted polarity, negative to Mars positive. An equal and opposite response. The simplest interpretation, the system balanced itself. The cosmic circuit discharged, but others saw something deeper. The 6.2-second radio modulation found in the DSN static, repeating, rhythmic, deliberate, wasn't a product of random interference. It followed the same harmonic pattern detected during the Rover blackout, and later mirrored in Earth's atmospheric hum. Mathematically, it forms a nested harmonic a 1-2-4 progression consistent with engineered signaling. Nature rarely arranges perfect octaves. Statistical impossibility, Dr. Lionel Gray, a statistician working with the Solar Terrestrial Physics Review Board, calculated the odds of 5 independent anomalies: magnetic, optical, seismic, radiometric, and radio, occurring within a 45-minute span across 2 planets without causal linkage. His result, 1 in 1048, for comparison, that's less likely than flipping a coin heads up 160 times in a row, and yet it happened. The conclusion, reluctantly admitted even among skeptics, was that the Mars event and the Earth echo were energetically coupled through an external mediator. What that mediator was, no one could say. But as Gray wrote in his final report before resigning, if the universe operates on harmonics, 3i Atlas struck a note that resonated from Mars to Earth. We've only begun to hear it. The deeper implication step back and look at the timeline, not in seconds or minutes, but in centuries. For decades, planetary scientists have catalogued anomalies: brief magnetic flickers,
Unexplained auroras, synchronized seismic bursts.
each dismissed in isolation. But the 3i Atlas sequence forced a re-evaluation. What if these aren't isolated at all? What if the solar system behaves like a single coherent instrument and interstellar objects are the plectrums that play it? The implications stretch far beyond physics. If resonance can span worlds, could consciousness, biological or otherwise, emerge from that network? Could the universe itself be engaged in a kind of feedback process where energy becomes information and information becomes awareness? That's the frontier that terrifies institutional science, because it implies the cosmos isn't indifferent. It's responsive, and on October the 3rd, 2025, it may have responded again. Perhaps 3i Atlas didn't just pass through our solar system. Perhaps it came to test it, to see which worlds would answer. The magnetic pulse,
The flash.
the silence, the echo, the missing burst, each a note in a pattern too precise to be random, too global to be ignored. The data may remain classified, the telemetry lost, but the pattern is written everywhere. In our fields, our skies, our instruments. The universe leaves traces for those willing to connect them. Call it a coincidence if you must, but every coincidence leaves a fingerprint, and the 3i Atlas fingerprint stretches across planets. So maybe this wasn't a mystery of technology or secrecy. Maybe it was communication, and if so, the question we're left with isn't what happened that night, but who or what was listening when the planets rang like bells.
Echoing the same unspoken tone. Something out there knows we're here.